Good afternoon, good evening, everybody. Nice to see we've got quite a few people here. My name's Rob Gould. I'm your host for this evening. I hope you like my Christmas decorated office. So welcome to Mainframers. This is my first time, so I expect it's a few of your first times, and I expect a few of you have been here before. But let's kick off. So, what is Mainframers? Well, we used to be a little group based in London, and we used to do face-to-face stuff, just talking about the mainframe, really. All the speakers you'll see today have been doing mainframe for some of them for a very, very long time, like myself, getting on for 30 years, some not so often. But we all have an interest in mainframe, and we all have an interest in letting people know what's going on with mainframe. So that's basically what we do. It's community driven, it isn't done by IBM. I mean, IBM organise it, to be fair. Matt Kamer is the lad that sits behind it. Unfortunately, Matt's not here today because he's ill, but Matt organises it. He works for IBM, but we've got people from all over. I work for a consultancy. We've got a few people that work for partners, a few people that work for ISV vendors, all on the organisation committee. So there's quite a few of us, different backgrounds, different jobs that we do now. I think most of us have worked at IBM in the past, to be completely honest with you. I've also got clients that come along and play, so that's good. We've recently hit 1,000 members, so that's amazing. So that's really cool. So if you're new, welcome. I hope you enjoy yourself. This is the 7th event we've done. We've done 6 before. We started at the end of 2018. Again, started off face-to-face. Sadly, given what's been going on over the last couple of years, it's obvious that we've been doing virtual stuff. So we intend to move back to face-to-face, but I think we're going to do what they call the hybrid stuff now. So we'll have people in an office, hopefully, or somewhere in London, actually talking to each other face-to-face in 3D, which is nice. We're not used to that. And we'll also have people on the line, because we know there are people outside the UK that now come and play. So that's cool. So what we're going to be doing today, so hang on, my dog's barking as usual. So this is a couple of the organisation people. If you look, you'll see me. I look very serious, and I look like I can play the guitar. Neither of those are true. I'd like to thank Sam. She's the one picking her nose in the bottom left-hand corner for sorting out this presentation, which is far beyond my skill levels. So those are the only 2 people I mentioned off of there. Because we need to skip on because we've got a lot of content to get through. You can find us on all these platforms. We'll be sharing these slides afterwards, so I won't go through and read them, but you can see what's going on there. And we're also on Twitch, which is a new trendy thing, which I have to confess I know nothing about. But there you go, that's fine. So if we go on to, if you'd like to become an organizer and come and help us, like I said, this is my first thing. Come and get involved. You can tell us on Slack, or you can direct message us and we'll get hold of you. Or you can come involved like I involved, which is where I went out with Alan and he bought me a very nice lunch and I agreed to it in a moment of weakness. So I think that's probably the best way to get into it, if I'm honest. But we've got lots of opportunities. We've got organisers. We do bi-weekly meetings every other Thursday. Bi-weekly. Probably about an hour every month. Probably not that, to be honest. The ones I've been on haven't taken that long. And we've got speakers. We've got 7 speakers today, including myself. Again, not much time. And we've got recruiters if you want to go out and find people to come and help us do stuff. And then we've got hosts. So I'm your host for today. Again, it says 1 hour a month there, but I put far more in. It must be at least 2. So if you want to be a part of the community, just come and attend events, spread the word. We know there's lots of people out there that are interested in Mainframe. So keep cracking on and telling as many people as you can. That would be greatly appreciated. Right, so the agenda. So these are your speakers for today. We've got Ian Mitchell. Ian is the IBM Z Strategic Modelization Leader, based out of Hursley, I believe. Ian's a distinguished engineer. He's going to be talking about the whole Z picture. Then we've got Helene Lyon from over in France, again a distinguished engineer. Helen is IMS royalty. I don't think I'm far off if I say that. So Helen will be telling us about IMS. Then we've got Ezriel, who works for Rocket Software. He's going to be talking to us about CICS. And then we've got Andy Lyell will be going and telling us about ZOS Connect. That's good. And then we've got Vaughn Marshall from Broadcom. He's chatting us to about Endevor. Vaughn did an excellent presentation at ESTG last week that I watched on Zoe. So I'd recommend that one if you can get hold of it. Then you've got me. It says business development lead. I'm the business development lead at Triton because I stepped back last, to be perfectly honest. I am a database consultant, so I do proper DB2 stuff as well. And then we've got Matt, who's going to talk to us about MQ. And if you're wondering, STSM stands for Senior Technical Staff Member, which is an IBM. So we've whizzed through that. If you want to stick any questions you've got, we'll be picking them up as we go through. So stick them in the Slack channel. That would be super. And we've got a survey that we'll be running afterwards. So if you'd like to click on that link and let us know what you think, ideas for next time, etc., that would be fantastic. So that's lovely. So that's probably don't need to show you that one just yet. So the plan is we're going to do 10 minutes each. You might hear me interject because if the other speakers are anything like me, talking for only 10 minutes is practically impossible. So I will be trying to keep people to time. And with that, I'm going to pass over to Ian. So I'm going to stop sharing, Ian, and it's all over to you.
Well, thanks, Rob. I am hoping that everybody can hear me and that everybody can see that we are now sharing a different chart. And well, again, I'll extend my welcome to everybody who's joined the session. It's good to see the numbers as they are this evening. I'm sure we've, in the summer, there's lots of alternative attractions. But I was also delighted when Matt Comer invited me to at least kick off and set the scene, as I've titled this chart, for this session, trying to explore and give an orientation to many of the important components of what you might call the ZOS platform. Just to give another little bit of context. So I've put on there that I'm now working in IBM consulting, so don't hold that against me. But that's only 18 months of consulting after 30, God, yeah, a very long time working on the Z platform, still in Hursley. But for example, I was the CICS product architect for about 10 years, which was probably the most enjoyable bit of my career. And I have stuck my nose into most parts of ZOS. So I was delighted to be asked, and I'm going to give you just what I think is a quick tour around some of the interesting components. So that will be confined to 10 minutes. Which I'm sure both Nick and Rob or Matt will hold me to, because I do have a certain reputation for maybe taking 20 minutes to get off my first chart. But anyway, let's get going. So having been a long-standing developer and architect, I couldn't resist putting in the standard architect's chart. I mean, this must have been I don't know who first used this sort of layout, but it's the typical platform architecture chart, and so that's what I'm going to use as the framework, just to introduce a lot of the things that you're going to hear about in the session in the segments later on. So, in the spirit of getting off my first chart, and because I have recently discovered the PowerPoint morph transition, I'm going to introduce all the things, or my first set of things, that I'm going to use to orientate how we have a platform based on the real strength of the ZOS operating system, but then what we often think of as the crown jewels, so the data that clients entrust to the platform. And that has been a long-standing principle on the platform, that the balance between what we do with data and the way in which we provide the most secure and resilient home for that data gets complemented by what we do with the apps. I'm going to talk a little bit about each of these in a sec, but just to orientate that stack. And then what's been happening for, well, I mean, I've been involved in various forms of APIs, seems like forever. It must be 12, 15 years ago when we started designing APIs. We did APIs through SOAP and web services. And of course, now we've got REST. But of course, along the way, the asynchronous world has been served very well by the MQ product. So I'd say another Hersley success here that really introduced enterprise level messaging and drives a lot of the asynchronous mechanisms that people rely upon. So we do see, and again, I'm sort of going to come down the picture again, just fairly speedily, but the prevalence of APIs as the way to really get value out of the platform has been a very, very strong initiative for a very long while. So API enablement, whether that's REST, Swagger, or asynchronous event-driven interactions with the rest of the world, that's really where the value of the applications gets provided. That's how you provide service to the consumers that need the data on ZOS. But if we just come back down through the stack of what we think, what are definitely application servers. So we've got IMS, and you'll see IMS is appearing twice on the diagram because we do have IMS TM as an application environment, and as well as CICS and WAS. And I was unsure whether to say WebSphere or Liberty these days, because certainly the move to Liberty as a open source and more dynamic and modular application server supporting all of the Java standards has been again a very significant move for the platform. And then I wasn't sure whether to put WAS or Liberty inside a CICS because that's also a very successful combination. I'd go as far as to say that most of the Java that runs on the platform is certainly in Liberty, and there's a good proportion of that is Liberty in CICS. But I'm sure Ezriel's going to talk about that shortly. So then the applications mean very little if they don't have data to feed upon, to manipulate, to serve out. Somebody wants to annotate the shared content. Well, I'm actually going to decline that, Stuart. And that data spreads itself across databases. So IMSDB, that's the sort of other half of IMS that Helene will talk about, as well as DB2. But we've got a hell of a lot of what we might call file access through VSAM, through the access methods that give you good old key sequence data sets, entry sequence data sets, all that sort of stuff. And we have all of that mixed together in the power of the application servers. But all of these things are really enabled by the power of the operating system. So all of the base security, integrity model that we get from ZOS, those are real distinguishing features that we get from ZOS. And then having worked on WLM, which stands for workload management, how we arbitrate the demands for workload across the platform is a real distinguishing feature, and all of the components contribute to that. And then, of course, we have batch running on ZOS. That is an extremely important element. So, can I get it? Yeah. But just to try all that together a bit, distinguishing features in my mind are the way that we implement transactions and transactional integrity. So I'm sure all the speakers are going to talk about transactions. And when folks contrast how ZOS works or how ZOS platform works, I think the integration of transactions is an extremely important thing. And as we look to adopt things like microservices, we're often having to teach the other folks how to do transactions, for example. And again, I'd say that one of the distinguishing features of the platform is the tight integration between these components, because we can think about the architecture, but it's the way the things work together, and typically with cross-memory integration, that really distinguishes how we build the platform. If we look at the languages available, having been around 50 odd years, we've accumulated quite a few. So we can look at assembler, didn't even mention that. But PL1, COBOL, Java, Node.js, we've now got Go or Golang. Golang is a lot easier to Google than Go, so I typically say Golang. And support for that in the different runtimes is always an evolving situation. But if you want to take your language choice, you can find those things on ZOS. And then just one ZOS ain't enough. One Z machine ain't enough. If we're going to provide the resilience, then 25 years ago, IBM invented Sysplex, which is basically the clustering technology to take multiple instances of all of these things and make them work really well together in a Sysplex. This relies on a technology called a coupling facility. But from the software point of view, we can do replication, we can do scale out as well as scale up. And we take all of those base characteristics and really scale them out to sort of unrivaled scale, but building on that resilience through the Sysplex. Now, if we think, well, we've got to develop stuff, we're going to hear about Endevor. We're here. My job at the moment, modernization, sort of is looking at modernizing runtimes, modernizing DevOps, and I've got development on one side and operations on the other. Maybe that's an old-fashioned style, but DevOps, we've got all the modern angles on DevOps. So IBM has WASI, IDZ. I deal with a lot of people who still like TSO and ISPF, but we then move them to things like IDZ or Topaz and ISPW, but also the new ways of doing continuous integration with Jenkins, new ways of doing SCM with Git, all complementing what we've had for the last 30 odd years, 40, 50 years. And then from an operational point of view, many choices, but popular ones, Megamon, SysView, MainView from vendors. And then I think, as was already mentioned, we bring that together. Zoe is a really important open source initiative, bringing together many of the components and componentizing a lot of the operations, as well as the development side of things. So really, that's what I was just really intending to take a spin around an architectural view of the platform. I hope that's sort of given a bit of orientation that can position what the rest of the excellent speakers are going to talk about. As we mentioned earlier, I'm going to now go in the chat, and I'd love to maybe take questions, or sort of while we're listening to the excellent speakers, if you got points that and clarification from things that I said that didn't really make any sense, but I hope that wasn't too many. But with that, I'm going to stop my sharing and hand over to my illustrious colleague to talk about IMS. Hello, Helene.
Hello, everyone. Okay, let's go present. Okay, so thank you, Ian, to introduce the middlewares and all that stuff. And you're a baby. I have 39 years of IBM.
Yeah. Okay.
I'm 32 on IMS. So I think I'm quite legitimate to talk about this discussion. And for people who know me, I'm a fan of IMS, and I accept to find some other afterwards. So what is good with the mainframe, and I find dinosaurs with two heads, because IMS is two middleware in one. And it's exactly what Ian mentioned already. And why we are still there, it's because we adopted since day one the mainframe design initial philosophy, which is we will protect customer investment. So applications that have been developed 40 years ago will still run today. Data that has been created 40 years ago will still be there. And iOS is one of the several middleware that is supporting currently application and data, as Ian mentioned.
Am I alone in not seeing your charts, Helene?
I can't see any slides. I was just going to mention that.
You don't see the chart?
No.
It's written that I share, so I stop sharing. Okay, let's do again. After 5 years of COVID, we will have very good tools, I guess. Okay, so let me. I don't know what happened. I'm not in the meetings, as he said. Do you still see me or hear me?
You can see you, Helen. Let me see if
Yep,
I can stick
yep.
your slides up.
So, and you don't see the slide. My network is up. I want to share. Well, maybe find the slide for me.
Do you want me to try and share it? Can you see those?
Yeah, we can see those.
Yeah. Can you see those, Helene?
No. That's often I will present without seeing the slide. Okay, anyway. So you are on the page which is written IMS, all you need in one.
I'm on. Yes, IMS, all you need in one. Yeah, go for it.
I tried to put all you need is love, but I could not find. So anyway, I love IMS, but IMS has been designed as a ZOS, like all ZOS middleware, to inherit all strengths of IBM-Z system. So it's really using all very good function of ZOS, like the one mentioned by Ian, is security, integrity, workload manager, and sysplex, and languages, all functions that are provided by the base, in order to provide a very efficient messaging and transaction manager coupled with a database manager. So it's two middleware in one, as I say. IMS TM has been based on an MQ, on a queue before MQ was there. So it has, we could receive like requests for processing, transaction processing, very high volume, very rapid response time. And applications are able to access not only IMS DB, but also DB2 tables and MQQ. And as Ian mentioned, transactionality is very good. And I'm really mentioning that one of the strengths of ZOS is clearly the transaction management between IMS, CICS, and WAS. And customers are sure we provide integrity when they access one or several resource managers. So it's very important. Over years, IMS evolved also a lot in order to support all type of application connectivity, requested by the business, 30 to 70 for sure, but also MQ and now API, and very important inbound and outbound. So when you are in an hybrid cloud world, you position the mainframe as a backend or as a front end of cloud services. So for sure, IMS application can call services outside the mainframe in order to be a real citizen of the hybrid cloud environment. Database manager, very old. It has been designed for a good reason. You will see the next page. And it's really a hierarchical database model. So the young folks on the call who should think it's very old-fashioned. Now we are relational, and I could say that DB2 is old-fashioned because people are thinking no SQL now, so it's fun. It's fun to see the evolution. But anyway, we are talking about business application, and those business applications that customer developed recently or a long time ago are running on those middleware, like even IMSDB, not on DB2, and they work. And the database connectivity, even for this hierarchical database manager, can be also JDBC and DRDA. And they provide modern tools, so Eclipse base doesn't seem to be modern. Eclipse tools are not maybe the last interface to access, but we also have like VS Code and Python access to IMSDB, so it's working quite well. A big also advantage of IMS, as Ian mentioned, there is also the batch application. So in banking and insurance, like in many industries, there is a batch at the end of the day, batch at the end of the month, batch at the end of the quarter. And IMS has provided since day one a very efficient batch manager that can also provide some transactionality capability for application that access several resource manager like DB2 and MQs. So very used by customer. So let's put one slide, next slide, if you have page 4. I can't see the screen, that's really stupid. But so historically, IMSDB has been developed long time ago to manage the large bill of material for the Apollo space program. That's why it's hierarchical, because those bill of materials, they need clearly hierarchical. And today, after 54 years, so IMS is processing a lot of transactions around the world. And like for CICS, on ZOS, we reach a very high throughput per second. So you can imagine why customers use that. It's really for transaction per second. And in a Sysplex environment, can you imagine that some customer reach their 10,000 transactions per second on accessing the same database copy on the same database? So it's incredible. I just love this platform. So in the handout, you will have some quotes of some customers. So you see some banks for sure. You see some manufacturer and insurance. So it's a good switch to the next page, where it shares like who are the customers using IMS. So IMS TM, so page 5, if you can go. Maybe you are page 5 already.
Yeah, no, I'm on slide 5.
Okay, so what is the client base? So it's half of the ZOS client, and you will see that CICS is much more used by almost all customers for good reason. And some use IMS Transaction Manager only with DB2. Some are using IMS TM, CICS, CICS with IMSDB, and some are using TMDB plus CICS plus DB2. So for it's good deal for IBM when customers are using the 4 middlewares. Plus was, I should say. So the client base is stable. I can see some customer who wants to get rid of IMSDB because they want to use SQL, but some do have only IMSDB and no DB2. So there is politics over there. So you can see that we reach all industry. And even if North America is well represented, Europe is a big IMS, is a big country for IMS. So interesting job to get, interesting learning experience in order to do that. So page 6, I reuse the slide from Ian, and I position the direction. So open and connected, APIs, you will see ZOS Connect for sure. We talk about Java in IMS application. So not in a Java server, but maybe potentially in IMS. A lot of enhancement regarding data to make it more vital, to make it more accessible, to put analytics on top of IMS data. And for sure, like every middleware, we want to provide performance and security all the time. So that's key feature from everywhere. And on the development side, as we are part of the game, as Ian mentioned very quickly, and on the operation side as well, it's quite important to provide those new capability, especially in the hybrid cloud world, like Zoe integration. You will talk about Zoe, like providing capability in an hybrid cloud world with Ansible to be able to interact with IMS and do rapid provisioning, for example. If you want sample, next page, if you want samples, stuff like that, you can start by this page, you know, on GitHub, which has a lot of IMS information. And that's it for me. 10 minutes in, 10 minutes exactly.
Thank you, Helene. Right, I finished my slideshow.
Yeah.
There you go. I'm not sharing.
See if you can see mine.
You're starting to share content. There we go. Jobs are good.
Okay. Well, welcome. My name is Ezriel Gross. I'm a Principal Solutions Advisor at Rocket Software. And today, let's see if I can advance my slide. It's not advancing. There we go. So, yeah, same problems, Helene. Thank you for that presentation. So CICS or CICS or Customer Information Control Systems has been around almost as long as IMS. Not quite, I guess a year less, in the late 1960s, right? The product came out, of course, as middleware. So you're hearing a lot about middleware today. But it was designed so that you could build applications more easily, right? So in the early days of computer science, right, you had to communicate directly with the machine to get almost anything done. And in order to build applications, it was thought that if we built some middleware to make the design of applications a lot simpler to do, then it would get a lot more uptake. And it actually did. So if we just transform till today, you would see that CICS, right? And the current release is CICS version 6.1, which came out on Friday, as a matter of fact, has quite a number of users. We process at least 1.1 million transactions per second. There's over 200 billion lines of COBOL. And again, these numbers are probably not 100% accurate because it has changed over the last couple of years, but nonetheless, it's a quite heavily used product, and it was designed so that people could build applications more easily, right? And so I'll show you a little bit about the product itself, but effectively, as we've been talking all along, this is a piece of middleware, right? So you build some applications within CICS, right? So that it communicates directly with things like ZOS and files and databases such as IMS and DB2. And again, it's middleware. So it has the ability to manage the user interface. There is a whole 3270 based interface, which is the old green screen. Whether you're using that or not, CICS will also support things like web services. You can use other utilities to build your front ends, and you can bypass that user interface management that CICS could do for you. But basically what it's doing behind the scenes is retrieving and modifying data for you and handling all the communication. So who uses CICS or CICS? The major users would be banks for things like mortgages or account reconciliation. Payroll was a big application for CICS. Brokerage houses tend to use it for stock trading and trade clearing, human resources access, and that kind of thing, and insurance companies. So those would be the top 3 companies that I've seen over the past, 30 or so years that work or have applications that run in the CICS environment. However, there are others as well. As Helene mentioned, in the world of IMS, you have some of the federal agencies within the government and other different parts of other industries also process their workload through CICS. So the first thing to try and get an idea of what makes this as a transaction processor different from what we originally had. So if you go back to the beginning of time, and we have it of course today as well, we have this concept of batch processing. But batch requests are really take a file, read through every record on that file, process one record at a time, and when you're complete, produce some sort of a report or update some records on a particular other file, right? It's used for things like order entry processing. Transaction processing is more interactive, right? So the online requests are generally received randomly, and they're processed immediately. You could think of them as web requests today, right? When you go to a particular website and you click on something and you get an immediate response, you could type in any piece of data that you want to, and it has to be able to retrieve that particular piece of data. So the results are transmitted as soon as they're available. The response times tend to be sub-second, especially in the world of CICS, right? And it's used for things like credit card authorization. So every time you go to a store and you swipe your credit card, if that credit card processing system is managed by CICS, you get an immediate response. And that's without giving away any customer names. Nonetheless, some of the features that you would expect to see within a transaction processing environment is you get large volumes of business transactions that you have to process rapidly and accurately. So that was the key behind CICS as it started out. You also had to support multiple users. In the early days, when you had 3270s, you have, well, could be up to 50 or 60,000 people logging on at the same time. And you needed a system that would switch between the different applications that needed to run from time to time. So you needed simultaneous access to the data, and it would be large volumes of data. And as mentioned earlier, we need intense security and data integrity controls, right? So you want to be sure you know exactly who's accessing the system, what level of access they have. Can they sign on to the system? Can they access a particular resource? Can they issue a particular command? So we have that kind of granular level of security. And we also have data integrity built into the system. So the application programmer doesn't have to think about data integrity. It just comes with the processing. So if you were to, I don't know, transfer $100 between your savings and checking account, then you want to be pretty sure that when it was deducted from your savings account, that it made it to your checking account. If something would fail in between, data integrity basically says the money should be restored to the original account it came from, right? And all that is built into the environment. And as mentioned earlier, CICS, for example, is a mixed language application server. It supports assembler and C and C++ and COBOL and PL1 and Java. And I probably don't have every language specified there. And we also have interfaces into things like Maven and Gradle, and we support Ansible and certainly web services. If I could get my paging to work. So let's just show you a little bit about the internals of a CICS application. So a transaction is considered a business transaction to us, right? So a business transaction would be, let's say, get my account balance, process a loan, right? And over on the right-hand side, on an old 3270, you might type in a 4-character TRAN ID, hit enter, you'd get a screen that says enter a part number, for example. You'd type in the part number, you hit enter, and you get a response back. So that would be a business transaction. But how that's broken up under the covers is a transaction itself is made up of these individual tasks, right? So every time you get a response back, it's almost considered a task. And a task is that logical unit of work that has to be recoverable. It could involve many different programs, right? And you could have many tasks that make up that business application. But each of these tasks tend to run concurrently, which is how we support the whole concept of multitasking, right? So each user gets a brief amount of CPU, and this is the way we can support, you know, tens of thousands of users processing in a single system at the same time. My paging is not working here. Okay, so one of the big things in CICS that you learn about when you start out is conversational versus pseudo-conversational programming. Most of the programming today is conversational, which says Well, I'm going to actually take some input data from you and I'm going to send you back a response, but then I'm going to wait for the next level of input. And if we did something like that in the world of CICS on a day-by-day basis, we could never support the level of access that we do today. So you wouldn't be able to support that many users if every user has a program running in the system that's waiting for some sort of a response. So there's this concept of pseudo-conversational programming. And this is the only thing that when you start out in the world of CICS that you really have to get your hands around. And that is, whenever we get to the end of a logical unit of work, we basically end that conversation, end that task, and as far as the system's concerned, we're done. You're not even there. If a user comes back and hits enter on a screen after entering some data, then we'll start the entire process over again, but we'll remember where you left off. And that is the concept behind pseudo-conversational programming. So when you look at this chart over on the left-hand side, if you have an application that runs from beginning to end, then you would see that you'd have a series of waits in between, which means the system has to remember everything as to where you left off. There could be storage associated with you. There could be locks that you maintain on particular records or databases. And so that would be conversational programming, and that wouldn't really work very well in a large environment. Pseudo-conversational is really about providing the user with some sort of a response, remembering what state he was in, so that if the user comes back and wants to process the next level, as you saw in the example earlier, they type in part, they get a screen, they fill out that data on the screen and they hit enter. But if they don't fill out that data on that screen and they decide to go to lunch for an hour, you might be looking at that screen, but the system has absolutely nothing running. And that's what will allow the level of multitasking that CICS supports. So in terms of development, we tend to break it up into three different pieces. There's the presentation services at the top. Most of that today is done by other platforms, right? Because nobody's really interested in a green screen anymore. And so that's where we get into things like web services or ZOS Connect, right? Because some other platform is providing that presentation service. What CICS is still really, really good at is providing that business logic, right? That data manipulation and computation that you do on the data itself. And then you have the data services at the bottom. And again, that could be things like simple vSAM or IMSDB or DB2 or an outbound web service to a completely different server. So we really fit very well into the center of that picture, business logic. Now, just to give you an idea of a flavor for how a program, let's say in COBOL, differs in batch from online, is they made the development of applications much easier by simply inserting exec CICS commands. So an example would be exec CICS read a particular file with this key into this area, right? And then at the end of that command, all you really had to do was verify whether it worked successfully or not. And if it didn't, what were the error codes and how to transmit that back to the customer. So if you look at a batch program versus an online program, the online CICS program just has a sprinkling of these exec CICS commands. So we accept the fact that CICS under the covers will provide these services for us. So we don't have to worry about them, right? So that's how a program might differ between batch and online. So again, hopefully I've kept to my 10 minutes as well. It's ideal for transactional environments. It still provides the core of the business logic to most industries today. And again, it provides the availability, maintainability, and scalability that we need in our large scale environments. At the end of the presentation, I provided some further reading links, and I'll just put that up for a second or so. So if you get this presentation later, you can always type it in, or maybe it'll be clickable for you to be able to see that. So that's all I had for today. And now I'll pass it off to Andy, who will talk to you about some ZOS Connect.
Thanks, Ezriel. Can everyone hear me?
Yeah, we're good.
Yep. Thumbs up, terrific. I'll share my screen. Hopefully I won't mess that up. Slideshow mode. Start. Can you see my screen? I hope so.
Yeah, that's cool.
Terrific. Right, let's go. My name is Andy. I work as a product designer on a product called ZOS Connect, and it's kind of quite time that Ezriel will pass off after mentioning that CICS provides a lot of core business value. So what is ZOS Connect? Well, it's actually a very simple product. You can create RESTful APIs to enable ZOS applications and data. So Helene and Ezriel were talking of CICS and IMS and years of fantastic mission critical transactions that run on the mainframe. Well, today, where a particular flavor of access is RESTful APIs using JSON, that is exactly what ZOS Connect is for. So not only to enable all that good stuff running on your ZOS mainframe, but also you can call out from applications and data that run on the mainframe as well. So you can call in, you can call out. So if you had a CICS program, you can call out to a RESTful endpoint somewhere on the internet and do some processing with that. Originally released in 2015 as a version 1, and as you can imagine, it's now 2022, so we've made some improvements which I'll go into. But none of the prestige of IMS and CICS and the the longevity and the world that they inhabit. So who knows how long ZOS Connect will be around for, but we're pretty young compared to it. And it's good to mention that really, the basis of this is it's a very simple product, but how it does it is quite complex, and it's able to transform JSON data to COBOL and PL1 and back again. So why would you use ZOS Connect? Where does it sit? And Ian mentioned it in his presentation as well, that been doing APIs on the mainframe for actually quite a long time. Well, what ZOS Connect was able to do was say, well, for the subsystems, we're going to do it in one way. So you have different methods and different ways of getting that data from IMS, CICS, MQ, and others. But ZOS Connect was able to say, you learn this, and you'll be able to access all that data in this particular way. So you reduce that learning curve. We offer a quick and easy visual API creation tool. We call it the API Toolkit, and this gives you a no-code approach to create those APIs. And for those of you that deal with APIs, it's the Open API Spec 3. It's the standard. If anyone's familiar with SOAP, it's kind of comparable to a WSDL document. And what this tool was able to do was produce a Swagger doc, which is what Ian mentioned earlier, as that consumable artifact for the teams working to enable their applications and data to kind of distributed mid-tier. So there's even more power to this, which is you don't need to change all that good stuff that you've got already running on your mainframe. So if you had a CICS program that queried a database, you just say, well, what are the interfaces to that program? Put it into the API toolkit, and we can just use those without interrupting the program underneath. We have to recompile it, and we maintain that integrity as well. And of course, as you can imagine, well, a super bonus of that is that the security and the decades of incredible resiliency and downtime is, again, not compromised by API enabling what you've got on the box, which is pretty neat. So who uses ZOS Connect? Always important. The first is we have the systems programmer who will install a ZOS Connect server. This is where you deploy APIs. And then we have our application developer who has, like many of you guys starting out, who has knowledge of CICS and IMS and how they work. He'll be using that API toolkit to create that special mapping between the interface that gets produced, the Swagger, and used by distributed teams and wherever else needs to use it, and that communication between the ZOS artifact. What does ZOS Connect do? I've kind of already alluded to it, but as you can imagine, we have a CICS program, we want to API enable, we have the request and response copybooks, and it's written in COBOL. COBOL is vastly different to JSON, and it is able to do that data interchange between a RESTful JSON request and then pass that along in the language it knows how to talk to, let's say COBOL, so it does PL1 as well, to the CICS program or IMS transaction or MQQ, which I'm sure Matt Leming, he'll talk about MQ later, but it has this power to do this, which is pretty fun. Why is it integral to the industry? Well, at the moment, most of the financial institutions plan or do use APIs already to generate additional revenue. As you imagine, you have all this incredible wealth of mission critical applications and data sitting on the mainframe, and it allows you to expose that or call out from that to provide extra value and really make what's running on the mainframe not work harder, but perhaps work smarter, because you're enabling it to another audience and another economy, which is pretty useful. So quickly before I end, what's new with ZOS Connect? Well, where the tooling today will produce a Swagger document, we've created a new set of tooling that allows you to start from an open API specification. So that bit with perhaps a complex API that your business want you to conform to, you can now import that and say all those JSON structures and the API governance board that's taken time to create JSON schemas associated with objects and items. You know, you can map directly to that. You don't have to generate that up from the bottom. It's a web UI for creating these APIs, and it has something in it called JSONata, which is an open source JSON transformation and querying language. And what it allows you to do is far more complex transformations. So you can put fields together, you can apply logic and say, well, I'm receiving it this way, but I want my CICS program to be able to do some extra processing. So I need to change it into another format that it's going to understand. And that's an extra layer of power we deliver. We've also got a server image for ZOS Connect. If you wanted to run it on OpenShift, on Linux, on Z, we offer that as well. So that will run on S390X. So pretty exciting. And then I'll just finish off where if you want to learn more about ZOS Connect, you know, we have a good GitHub pages with samples you can try. The new tooling itself is completely free to use. You can grab it and play with it. All you need is a container runtime, and if you've got Docker on your machine or Rancher desktop, you can give it a go and have a play. And if you do, let us know what you think. We're always looking for feedback to improve, and we have some good documentation and some product information as well. So I'll finish there. I believe that's the last slide. Yeah, and hand over to Vaughn. Thank you, everyone.
Sandy. Let me just share out my screen. 1 sec. Can everyone see this?
Yeah, that's good.
Okay, beautiful. All right, well, thank you for having me. My name is Vaughn Marshall, and I'm a product manager in the Mainframe software division at Broadcom. I came over to Broadcom with the CA Technologies acquisition. So, you know, I formerly worked in Mainframe prior to joining Broadcom. And I'm in the DevOps value stream, which is home to a product called Endevor. And Endevor is, let's take a few seconds to advance. There we go. So Endevor is essentially a mainframe native DevOps SCM lifecycle management tool. It's been around since the 80s. It was actually first released as a commercial product in 1986 by Condor Technology out of New York City. Back then it was called Control One, and if anybody here uses Endevor, they've probably heard of the term C1 defaults and things like that, and that's where that comes from. But around, I would say the early 90s, it got rebranded as Endevor C1 and then simply Endevor. And one thing that I like to point out when I'm kind of introducing Endevor to people is that it actually is not a misspelling of the word endeavor. It is an acronym, and it stands for Environment for Development and Operations, which, if you think about it, should ring some bells when we hear these days the buzzword DevOps. This is really DevOps before DevOps was a thing. And I think that accurately kind of summarizes what Endevor does. You know, basically, when you are developing code for some of these critical systems that we've been talking about, like CICS, IMS, etc., you know, you need something to manage that development and automate it and make sure that as you deploy it through to production, you're following, you know, a proper process, everything is secured and so on. And that's exactly what Endevor does. And if anybody's interested, actually, very recently, Tracy Reagan at the Continuous Delivery Foundation published an article on IT Chronicles called The History of DevOps that talks quite a bit about Endevor. And
her memories of how it was used and how it's contributed over the years to what we kind of now call DevOps as a practice. It's used widely. It's at Fortune 500 companies. Quite a number of those companies use Endevor to manage their development process for their systems of record. And of course, it's continued to evolve over the years. So what does it do? Anyways, like I said, it's an SCM and lifecycle management tool. You can see on the right-hand side that it kind of actually covers a whole bunch of different separate things that you would today probably have different tools for if you were not developing. Let's say you were using kind of developing for a cloud native stack or distributed technologies. So there's version control, there's change tracking, so you can track your changes against requests for change. When you make changes, builds get done. You can package those things up and promote them. And of course, in the time that we've had this product and have been continuing to develop and improve it, we've built all sorts of integrations into other things. We also have we have something called Zoe CLI, and a Zoe CLI extension that allows you to, through a simple command line interface, integrate into the world of hybrid IT. So I like to think of it as kind of the comprehensive solution for managing development on ZOS. So let's actually, one of the best ways I think of to kind of show what Endevor does is through a picture. So let's compare what a software developer that's maybe developing for distributed systems would do these days. So typically you're going to have some sort of agile PPM tool that is giving you essentially your work, whether it's user stories or defects or things like that for the features you're working on. Typically you will have an integrated development environment. So Eclipse, IntelliJ, or if maybe you're doing .NET development, you would have Visual Studio Code. These days, VS Code is becoming very, very popular. There's actually surveys done by Stack Overflow that kind of talk about all these tools and their popularity. And VS Code, I think, is now at 75% of the most desired IDE out there. And basically, you would be making changes to code assets that would be stored in some sort of version control system or SCM. Now, in the world of distributed development, that's pretty much become some flavor of Git. So whether that's GitHub, GitLab, Bitbucket, Azure DevOps, there's some flavor of enterprise Git and connected to your IDE, and you're in there making changes, usually tagging things against your user stories and defects. And then as you do your commits, you usually have some sort of continuous integration server. Now, sometimes that's built right into the enterprise Git platform, but sometimes you're using another tool, a CI tool, one popular one being Jenkins and Jenkins Pipeline. And of course, when you do the builds, you're probably calling out to a tool that does the actual build. So maybe if it's Java, it might be Maven. If it's a Microsoft language, it might be MS Build. In addition to doing the builds, though, you're doing testing. So you'll run your unit test. You'll probably do some sort of static application analysis with a tool like SonarQube. And then at the end of that build, you're going to take your build products or binaries and you're going to put it into a binary repo. So tools like Sonatype's Nexus or Artifactory from JFrog. And then finally, you'll have probably some sort of release automation or orchestration tool that will take the stuff out of the binary repo and send it to different systems, to deploy it and then maybe even run automated tests against it. So all of that happens kind of with all these different tools, sometimes integrated, sometimes there's manual steps in between. But if I wanted to compare that to Endevor, basically Endevor sits kind of in all those spaces. So for instance, if I'm in my green screen editor, something like a quick edit, I would go in, I would fetch my code, I would work on it in the green screen environment, and then as I make the changes, it would automatically build. So continuous integration, if you will. And in Endevor, we have automated processes called processors that basically respond to events that you're doing in there, and it can basically automatically perform the build. The binaries gets stored in Endevor. So again, playing a role somewhat like a binary repo. And then you can package those changes up, and then you can actually orchestrate those changes through deployment to various levels of environments, whether the test to acceptance, and you can even ship to remote LPARs with something called package ship. So all of that is function provided by Endevor. Now, as I mentioned, I talked about the green screen flavor of this, but of course we have, a lot of traditional mainframers retiring and a lot of new mainframers coming on board that want to use these new processes and tools. So we've been making sure that Endevor keeps pace. You can actually integrate Endevor into all the tools in the above through things like Zoe CLI. There's also a bridge that can connect a Git repo to Endevor. There's even tools to decouple Endevor builds so you can run them when you delegate all of your version control to a tool like Git. So we have a very wide array of modernization options. So it's not just for green screeners. But that said, it works very well on the green screen as well. So that's kind of what it does in a nutshell. Why is this integral to the industry? Well, simply put, a lot of the systems of records at a lot of different companies are managed and and held securely in Endevor. And if you think about it in application source code, I think that's one of the most valuable pieces of an organization's IP. Maybe that and the data. But nonetheless, that is managed securely and reliably in Endevor at scale. We have customers that have many, many, many millions of elements in Endevor. And of course, it's been around for at least 30 years. And during those 30 years, people have been investing in automation and building up around Endevor. So, you'll find out in the wild that people have integrated this heavily into their change control process, so that there's all sorts of automation there around deploying things to production and making sure that, dependencies don't get missed or code doesn't get regressed and things like that. And more importantly, now that you've got these new tools and processes in place, the fact that you can easily integrate Endevor into that ecosystem means that it should be even more important to organizations as kind of a critical piece of managing their hybrid IT infrastructure. So that's pretty much it. So once again, thanks for letting me present, and I'll pass it on to the next presenter.
Super job. Thanks, Vaughn. So this is my go. So hopefully you can see my screen. I'm going to assume that's a yes. Right.
Yeah, you're all good, Rob.
Right. Lovely job. We're good. DB2 for ZOS. So I'm Rob Gould. I'm the business development lead by mistake, as you heard earlier, and a database consultant at Triton Consulting. So what is DB2? So DB2 for ZOS is a highly scalable, highly available relational database which runs on ZOS, fairly obviously. There is a DB2 for LEW. I also do DB2 for LEW. I do a bit of both. It's a very similar product, but it runs on little boxes. So we're talking LEW stands for Linux, Unix, and Windows. So that's what that one is. There are a lot of similarities. There are also some glaring differences which can trip you up, but I won't go into those. So DB2 for ZOS, note that when it was released, it had a big B, and it was V1.1. We don't do Vs anymore either. So that was released on the 2nd of April 1985. My first interaction with DB2 was I upgraded 2.1 to 2.2, and that was in 1988. So the latest one, DB2 with a little b, 13, we don't do Vs anymore either, was generally available a few weeks ago on the 31st of May 2022. So we've got through quite a lot of versions in the days. What does it do? It's really quite clever, massive throughput. So this is a system that I have actually worked on myself. So this isn't we put together loads of mainframes in a lab and see how fast we could do it. This is a real life internet banking system. We run 24,000 transactions a second. And that's 24,000 bits of SQL. So, I mean, that's pretty amazing when you think about it. So that's pretty stunning. Designed with a never go down philosophy, not a rapid reboot one. So the plan is to keep it up 24/7 all the time. You do have to take outages now and again, but there are many ways of not taking outages. We upgraded this particular internet banking system without taking an outage. So, you know, it's possible, it can be done. So it's a very clever piece of kit. Like I said, I've been working on it since 1988. So I know bits and pieces. Right, what is a relational database? It was very difficult to work out what to tell you about DB2 in 10 minutes because I can talk about buffer pools, which I don't even mention in this presentation for about 2 days. So I've chopped it down quite a lot. But the difference between a relational and a non-relational database. So this bit down here on the right-hand side, which looks like an Excel spreadsheet, probably because it is, that is a non-relational database. The bit on the left-hand side is a relational database. So what we've done is we've split it into little what we call tables, but they're all related. So this one up in the top left-hand corner has an item number, which is also in this table down here. And the bottom table has got purchaser IDs, which hold addresses, and that's also in the table as well. So that's what a relational database is. Accessing DB2. So I just stuck this one in. Basically, you can get to DB2 from pretty much anywhere these days. IMS can talk to DB2 and vice versa. TSO batch, this is what Helene was talking about earlier and what Ian was saying. You know, you run batch jobs against DB2, you can query it using TSO. CICS, so that comes in there as well. Distributed, this is a very 1990s, oh, hang on, what happened there? This is a very 1990s World Wide Web symbol that IBM used to use a lot. And as you can see, it's also a very, very old laptop. But basically, you can come in distributed and you can connect thousands of threads into DB2 at the same time. So that's good. And the call attach or RS, I left that in there. That's generally ZOS to ZOS communications. So it would use call attach or RS. So you can get to DB2 from pretty much anywhere. The other bit which I thought was important, so this is the high availability and massive throughput bit, and it's DB2 data sharing. And effectively what you have is you have one database at the bottom on shared disks, and you have a number of what I always describe as DB2 engines, which run against these shared disks. Now you'll see I've mentioned locks with the little padlock things. So basically if DB2A comes in and wants a bit of data and wants to update it, it'll take a lock so DB2B can't come in and update it. But as you saw on my previous slide, the fact that you can run a piece of SQL or 29,000, whatever it was, in a second means these locks just come in and disappear within milliseconds. So it's a very, very clever piece of kit. And in order to upgrade these, what you can do is you can actually upgrade them one at a time. Someone's hoovering in my face. You can actually upgrade them one at a time. So you can stop DB2A, you can upgrade it to version 13, while DB2B and DB2C are still running at version 12. And when you bring that up at version 13, you take B down and you do a rolling upgrade, which means you don't have an outage, which is very useful. It also extends the processing capacity because you can only get so much grunt through one ZOS LPAR. Hopefully you know what an LPAR is, but one ZOS machine. But with this, you can connect as many together as you like. Some of my customers have got 6 connected together to get as much throughput through as they possibly can. So that's DB2 data sharing. So why is it integral to the business? Well, you know, the capability of providing concurrent hardware maintenance and upgrade and rolling changes to DB2 mean fewer database outages. DB2 for ZOS is used by 25 of the 25 worldwide banks, 23 of the top 25 US retailers, 9 of the top 10 global life health insurance providers. There's also a massive footprint in government agencies all over the planet. New and exciting bits that are coming along. I told you that DB2 13 was announced just a little while ago. Z13 is the next boxes. They've been announced, but when the Z16 box turns up and you've got DB13 running on it, you'll actually be able to use within DB2 the on-chip AI function, which is going to be on the Z16. So that would be very interesting to see what people want to do with that. On top of that, we've got the NoSQL stuff. So we've got JSON. We've also got the REST APIs. They work against ZOS DB2. And we've also been doing so that enhanced security. So we're talking encryption on disk and encryption over the wire and all that kind of clever stuff is coming in. Well, it came in with version 11, to be honest, but now we've got 12 and 13 extends it even farther. So hopefully that's been an interesting overview of DB2. Because that's it from me. So I'd like to thank you very much. And I will end my slideshow. And I will stop sharing, he said optimistically. And I'll pass over to our next speaker. Oh, there we go. Well done, Matt.
There you go. The unfortunate thing about switching is suddenly the mute or unmute button suddenly disappears off the top of the screen. So hi, my name is Matt Leming. I'm the architect for MQ4ZOS, based in Hursley, along with CICS and ZOS Connect Enterprise. There you go. Right, hopefully you can see my slides. So what is it? I'm going to start off by saying, applications are quite complicated things, obviously, right? They're not normally single processes that run by themselves. They're normally, something closer to this black and white picture in the top right-hand corner of my page, where you have multiple different application components communicating either, via cross memory or over the network to actually get something done. And it's quite natural to think that when you do that communication, you do it synchronously. If you're using TCP/IP, that's a synchronous protocol. So that means both ends who are talking to each other both need to be available at the same time. And if actually your communication isn't really between two things, it's between a thing which talks to a thing and that talks to another thing and maybe that talks to another thing, you start to get all of these interdependencies lining up to give you quite a fragile environment, because if one bit fails, you suddenly lost your application, right? It's not very resilient. And as applications need to scale, normally each individual component, you don't just have one of those, you have many in order to give you the scalability requirements you need. And so then you start to be getting meshes of communications, and they can be very, very fragile things. And also there's also a lot of mesh going on. And then of course there's things like latency and all the rest of it. So, synchronous communication is all well and good, and obviously it's used very widely, but there is a really big use case for enterprise messaging, which is all about communicating asynchronously. And the idea here is that rather than applications talking directly to each other synchronously, instead they kind of communicate via a middleman or a middle thing. And in many environments that's called a queue. So you can see I've got this kind of little grey and blue picture here showing a pair of applications. So on the left we've got like a pale grey box, and it wants to communicate with the darker grey box on the right hand side. And rather than doing that directly, instead it sends the data it wants to communicate, and that data might be a command, or it might be some data that needs to be moved to somewhere else, or it might be a file. And it sticks that data on the queue, and once that data is on the queue, that application goes and does something else. Okay, so it doesn't have to wait for that data to get to the right hand side, because this is, it's passed the message onto the queue and it's done. And now the application on the right, when it has a moment, goes and gets the data, the message is off the queue, and does whatever necessary processing is needed to do on it. And then maybe it will send a response back to that original application via another queue, or maybe it won't send a response back at all. And this sort of message passing paradigm is really neat, because for starters, neither application needs to be available at the same time. And you can tolerate here gaps in availability that are really minor, or maybe you can deal with gaps that last for minutes hours, and customers are now thinking about what happens if my applications go down for several days at a time, in the worst case. And messaging and MQ is designed to deal with that sort of scenario. But it's not always about applications going down. Sometimes it's just about peaks of workload where a lot of work suddenly comes in and the back-end application hasn't got a chance to kind of process all that work concurrently. So instead, what it does is it sits there and works through the data on the queue. So the queue's temporarily holding maybe 10,000 requests, and the back-end application doesn't have to get overwhelmed by those 10,000 requests all at the same time. It maybe pulls off 100, processes those, pulls off the next 100, processes those, et cetera, et cetera. So that's kind of a shock absorber world. And another benefit of this approach is that it's also really easy to scale up and scale down. So if you imagine you do have this 10,000 load of work coming into your environment, maybe a single back-end processing application isn't enough to deal with that pile of work. So actually, you can scale up another back-end instance of that application. Maybe you scale up 5 dark grey boxes, and they sit there and collaborate together to pull the messages, the data off the queue and process them in parallel. And then when that peak of work is gone, you can kind of shut down some of the applications so that you're not using more resources than you need. And so this is really what messaging is about. It's passing data, whatever that is, via a queue. And then, of course, you've got the things that manage the queue, and that's what MQ for z/OS is. So what does it do? So, when I was starting off, I was saying applications need to communicate, and they often need to communicate over quite wide environments. And MQ has always been about having a queue manager, the thing that has and owns these queues wherever you need it to be. So we've kind of started on the left, and MQ's been around for about 28, 29 years now. And obviously it started in the on-prem environment. So we've always supported a wide range of different operating systems. We've had Z for pretty much forever, but we've had AIX for a long time, Windows, Linux. And then we've had some sort of more niche environments, IBM I and HP Nonstop, or Tandem NSK, if you want to call it that. And these environments have evolved a little bit over time, but as operating systems come and go, but kind of that core set has been with us for a long time. More recently, the last 6 or 7 years, we've kind of added a hardware form factor of MQ, which is the box down the bottom. And that's literally just a version of MQ in an appliance. And if you want to have high available messaging, you don't need to go and provision a server, install MQ into it. Instead, you plug it in, wire them up, and you've got a very high performance messaging environment. And the reason all this is important, and the reason I'm not going just on about Z, is applications don't just run on Z. They run all over the place. Often they need to access the data on Z, and they might do that by MQ. But it's really important to have messaging in all these environments. And then, of course, the world has evolved. Not everything runs on-prem, and MQ has been running in the cloud since cloud was a thing, whether that was in virtual machines or more recently containers, and then Kubernetes, Red Hat, OpenShift-like environments. And then the last part, we don't just have software form factors. We also have software as a service form factors with MQ on cloud and AWS, where you can basically click a button, we'll go and provision a t-shirt size queue manager for you, small, medium, large, and we'll keep the environment running and up to date, and all you have to worry about is messaging. And the key value proposition of MQ is that all of these environments can talk to each other. So if you've got an application running on Z that needs to send data to an application running in AWS, they can do that via MQ and use the same APIs and the same messaging constructs. So just a little bit of a zoom in for what MQ on z/OS looks like. So there's the MQ bits, the darker blue boxes. So the main thing, the thing that owns the queue is the queues is the queue manager. And that's the bit that provides, manages the queue data in memory and on disk, gives you all that transactional reliability everyone's already mentioned, security and all that good stuff. And of course, the Z ecosystem is really important. So MQ runs with all of the all the Z middleware, whether that's CICS, IMS, Batch, DB2, and of course things like ZOS Connect as well. But because MQ is primarily a communication mechanism, we obviously need to be able to reach out of the Z environment. For that, we have a comms runtime, which is actually called a channel initiator, and that allows applications running on ZOS or running in the cloud or wherever to connect in directly to MQ, and it also allows queue managers to be meshed together in order to communicate data over longer distances. And a more recent thing for us is also REST APIs. So we've already talked about ZOS Connect Enterprise Edition, but MQ now comes with its own built-in web server to expose a messaging API in a RESTful manner. Now, obviously, on ZOS, resilience and high availability is a critical thing, and you've already seen us talk about that for DB2, so DB2 data sharing groups, and we have a similar concept with MQ on Z called the queue sharing group, and the idea here is a single queue manager doesn't own silos of data. Instead, we kind of go back a level. You can have a set of collaborating queue managers all working with the same set of queues and the same set of messages, and those messages and the queues are stored in coupling facility structures. And then your applications connect into the group as a whole. It doesn't matter which queue manager they connect to, they can access the data, and if there's a failure on that LPAR and the queue manager goes down, then the applications can connect back in to another available queue manager and carry on processing. And so last slide, I think I'm probably vaguely on time. So why is MQ integral to the industry? So just like you've seen with all the other subsystems, we are heavily used in banking, insurance, and manufacturing. I'm almost certain that whichever bank you use today, they have MQ in there somewhere. 85% of the Fortune 100 depend on MQ. All of the top 50 banks use MQ, and that individual customers would be talking about billions of messages per day through their whole MQ network. We're now kind of reaching the trillions of messages. We've had at least a couple of customers saying that across our MQ network as a whole, we're moving trillions of messages, so trillions of chunks of data through MQ. And this isn't something that we're seeing slow down. As customers move to the cloud, they typically don't go to one cloud. They typically, use multiple clouds, or they have some cloud and some on-prem. And even if they're communicating inside a cloud, there's still a need for messaging. So the growth in messaging is kind of off the charts, and I don't see it slowing down anytime soon. So I think that's kind of me. So I'll stop sharing, and I think it's Q&A.
Here I am. Sorry, I had exactly the same trouble as Matt. My unmute button disappeared. So hopefully you can see that screen. So I'm not sure how this works, to be completely honest. We can go through the chat on the WebEx. I think that's probably a good idea. I saw someone had put a comment on there about hyperscalers pushing a solution to migrate people off of the mainframe. I don't know if anybody's got any views on that on the panel. My view is it's very easy to push, but very difficult to implement. I think that sums it up in one sentence, to be honest. Don't know if anybody else has got anything to add, Ian or Helene or anyone.
Well, I mean, typically we take a workload focused approach to try to understand the value of doing that. So there'll be lots of folks who have proof points that they've done it. Is that true? No, I'm not sure. There's going to be some folks who will promote the fact that they've done it. But equally, I mean, one of the things that I currently do in my consulting role, I sometimes describe my role as crime scene investigation. It's it's quite rare that I have the fun of looking at a really successful project. It's more that I come in and, as I say, do this crime scene investigation. So there's different approaches to doing that, of course. And we know that things like microservices are very popular at the minute, so splitting up the applications. But as I was alluding to at the beginning, the value proposition that sometimes is forgotten around how you construct these mainframe applications and whether we are doing synchronous or asynchronous communication, the co-location is a really important piece. And people forget that at their peril. So moving things about, I mean, it can work for some workloads, and particularly you would want to go the messaging route if you're going to do that. But there are some workloads where it just doesn't work. And as I say, crime scene investigation just proves that there's a almost inexhaustible supply of people who are surprised by this. So it's a thing to be done with your eyes open. I mean, one thing I am definitely sure of is that whilst I am a very wild enthusiast for Java, and then you can tell that I'm fairly enthusiastic about Python, but that's for a different set of problems. But Java on the mainframe or Java in general, is often a route that people see to convert from COBOL to Java and give them the freedom to recite their workloads. I mean, I must say, and this is Ian talking, not IBM talking, but I have yet to see a really good COBOL to Java solution. It often ends with not quite the outcome that you had at the beginning. I was doing a recent investigation for a client that was intending to use Spring Boot on x86 and had forgotten about the data access, forgotten about the security, forgotten about the transactional integrity, and was delighted by the recommendation to take that Spring Boot app and run it in Liberty and CICS and regain everything that they had forgotten that they'd lost until it came to actually putting the system together. So that's what has been deployed. Spring Boot Java apps in Liberty in CICS, accessing DB2 or vSAM or IMS is a thing to behold, a lovely thing to behold.
Fantastic, thank you. And if anybody's got any questions, apparently you can unmute yourselves and you can ask the presenters or anybody else that happens to be on. So I don't know if anybody's got a question.
So it looks like we've got a Kafka one, which is, on the distributed side, Kafka's very popular. Wondering when to use MQ versus Kafka, which I think has been asked by Machandra. So I might have obviously butchered that a bit, sorry. So, this is a question we get asked all the time. There's often a bit of confusion about when Kafka should be used versus MQ, because they're both, messaging technologies. And I think the Kafka guys do quite a good job of saying Kafka's a solution for everything. What's your problem? I think MQ, we tend to be a bit more honest and say, well, here's a set of things that MQ's really good at, and there's some other things that Kafka's really good at. So this, and so we've got some guidance. In fact, I could do a whole presentation talking about MQ versus Kafka and comparing them. So if you want that whole presentation, just give us a yell. Just contact me via email. But the basic way we kind of look at it is there's kind of three different scenarios. There's critical exchange of data. So when you've got your applications running and they need to exchange data and they need to make sure that when that data is sent, it gets actioned. And once it's processed, that it doesn't get actioned again. Do this thing for me, do it once, and then move on. And that's really the MQ side. We specialize in keeping data around for just the right amount of time until it's been processed. And when it's been processed, we throw it away because it's no longer important. Whereas Kafka kind of keeps this real-time event stream of data. So when you've sent a request for something, it doesn't get thrown away when it's processed, it gets kept. Okay, which is useful if you're trying to do like a stream of what's going on in your environment and seeing how your environment changes over time, because you can you've got this set of data kept in Kafka, and you can kind of start processing it and keep walking through that stream of data. And if you ever have to go back to see what happened earlier, you can kind of go back into the stream history. And that's something that Kafka is really good at, but MQ doesn't really do that. Although you can do it with MQ, it's not really what you should be using MQ for. And then there's kind of a middle ground. So in my presentation, I only really talked about queues and the fact that applications send messages from one application to another one. There's also this idea of publish subscribe, which is more of a one-to-many idea. So you have an application publishing to a topic, and then multiple applications interested in that topic, each receiving a copy of that piece of data. And that's something MQ does as well. But so does Kafka. And so you've kind of got this middle ground where if you're doing one-to-many communications, pub-sub, then both MQ and Kafka might be appropriate. And to figure out which one to use really requires you to get down to the second level analysis. And that's kind of not something I think is worth doing here. So, you know, it really does depend on exactly what you want to do. Often the answer is one of the tools, either Kafka or MQ, is the right answer. Then there's often a fuzzy middle ground, but it really depends on exactly your application rather than I want to do messaging on distributed. Kafka is obviously the right answer, because that's not the right answer. It's what are you trying to do?
And I want to add something about data consistency. You know, often we want to send onto Kafka some application events that are related to some database change, some processing. And we want this message to be sent part of the two-phase commit, so part of the transaction processing. And that can be done with MQ. It cannot be done with Kafka. So I would say today, I don't know if there is improvement regarding that, but so it's quite important, because mainframe customers, ZOS customers, are used to consistency. You know, starting by the base, there is one single version of the data accessed by everyone. You remember, every middleware person talk about locks that are put on the data to keep it safe during the unit of work. And MQ, DB2, CICS, IMS are the best doing that. So that's the discussion regarding MQ and Kafka that I have with the customer. And really promoting MQ for this purpose is okay. And then Kafka will manage the messages, the application event, as I call them, as Matthew mentioned.
Yeah, as far as I'm aware, there's no even sign of Kafka having transactional integration with other things other than Kafka, and that, you know, and that's a statement across the industry. So having the integration on the Z side seems, you know, way out if ever.
Right, super. Thank you, Helene. Thank you, Matt. So we were due to run until 7 o'clock, and it's now 4 minutes past. So I'd like to thank everyone for attending. I'd like to thank the presenters for presenting. I really enjoyed it. I hope everybody else did. And I'll wish you a good evening, and I'll speak to you next time. Thank you, everybody. Cheers, folks.
Cheers.
Thanks.
Bye.
Bye.